Friends, welcome to my YouTube channel. Today my topic is shear force and bending moment diagram for the simply supported beam. So first we will discuss one theorem, how the simply supported beam shear force and bending moment diagrams we can do. So I taken one point load in this theorem. So what we'll do, simply supported beam, first we have to find the support reaction. So here what is there? W kilonewton weight at the middle point. AB is the beam. So we can write here. Let AB be a beam and RA and RB be the support reaction. Support reactions. RA and RB be the support reaction. So first we'll find the support reaction. So simply supported beam, we have to find the support reaction, then only we can do the shear force diagram, shear force calculations and bending moment calculation and diagrams will draw. So what is the support reactions, how we'll find? So two equilibrium equations will apply. Summation of F b equal to 0. That means total vertical forces will be 0. So we can see here total upward force equal to total downward force will take here. Total upward force what is? RA and RB. So we'll take RA plus RB is equal to downward force is W. Give equations number 1. Now we'll take the moment about A. Taking moment about A. If A na, you can see B also. So always we'll take from our side. Okay. So taking moment about A na, this point is fixed. So what we'll do here? Total clockwise is equal to total anti-clockwise. Always will take. So here we are not assuming negative and positive. So total clockwise is equal to total anti-clockwise moment. So A point is fixed. What is the W moment? Clockwise. So W into L by 2. Taking moment about A. So this with respect to A, this force W, this is the perpendicular distance. Force into perpendicular distance L by 2. Now another force RB only. RB will be the anti-clockwise. So equal to RB into total length is L. Total length is L. So what will come? L by 2L. So if L will get cancelled, what will be the RB here? RB equal to L will get cancelled, W by 2. RB is equal to W by 2. Substitute this. Substitute RB in equation 1. So what will come? RA plus W by 2 is equal to W. So that implies what we'll get here? RA is equal to W minus W by 2. So W by 2. So that means RA will get W by 2. RB also will get W by 2. So W by 2 we got it. Now we'll draw the zero line. Where is the scale? Zero line. Zero shear force line will draw first. So RA is equal to here W by 2. I need that space. So shear force zero line will draw. From where we'll draw the given values. So this is the shear force zero line. Now what is the sign conventions? Similar things what we assumed at the cantilever beam. So before video cantilever beam already we did. So sign conventions always draw one section. Right side downward force positive, right side. Then upward force left side will be positive. If you will see here downward force, this is a section, upward force will be negative. Suppose we will take left side. If we will take left side, upward force will be positive and downward force will be negative. If we'll consider from right side, downward force will be positive, upward force will be negative. This is the sign conventions for the shear force diagram, shear force calculations also. Okay, so shear force diagram calculation now we'll do. So shear force at A, I am taking left side. Upward force is positive. What is upward force? W by 2. W by 2. Now shear force at C. C. So from here how much is there? W by 2 already is there. And this force coming minus. Because downward force will be negative from the left side. So minus W by 2. SC. Then what will be the shear force at B? Shear force at B, upward force will be positive from taking left side. So minus W by 2 plus W by 2 equal to 0. So shear force at B, 0. Okay, now we'll draw the diagram. So upward force, positive. So sign conventions we can write this side now, it will be okay. This space I need, that's why I am rubbing it. I will draw here. This is the section. Upward force left side, downward force right side will be positive. Now downward force, upward force will be negative. This sign convention. So here what is there? W by 2. So positive. In between A and C, no load, so horizontal line. So point line or no load means horizontal line only. Now in this point C, sudden change will be there. So how much is coming here at point C? Minus W by 2. So it will go down. This is W by 2 minus W by 2. Again C to B, no load. So again will be horizontal line. And in this point again it will go, this point is 0, shear force will be 0. This is positive shear force diagram, negative shear force diagram. Point A, point C, point B. So shear force will be 0 at the middle. So this is the shear force diagram for this particular problem. So now we will calculate the bending moment. So the line will extend this. So we will draw the bending moment. A light line you have to draw by the pencil. So already you know where will be the shear force 0, bending moment will come maximum. So okay, so now bending moment diagram. This line you hatch it because this is shear force diagram came now. So this you hatch it. This is the shear force diagram. Now bending moment diagram calculations will do. So bending moment diagram calculation. So what we'll do here? Bending moment A will be 0 because if you are taking A moment, because moment is nothing but force into perpendicular distance. So RA is force, but in this point A we are taking no force, so 0. Bending moment at B also will be 0. Bending moment at B also will be 0. Then what is bending moment at C? So this point is C. We will take left side. So here also sign conventions will write here. Draw one sections. This is clockwise. This is anti-clockwise. We will take negative from right, from left. If we will go the downward, this is clockwise. This clockwise, so this is anti-clockwise. This is clockwise, this is anti-clockwise will be positive. This sign conventions will take. So this is the clockwise. So we'll draw the diagram first at the 0 line first. Bending moment at 0 line. We draw the 0 line, okay. So this point bending moment at A 0, bending moment at B 0. Then bending moment at C we have to calculate. So we are taking from this point. So it will go left side. This is left side. So left side clockwise. This is called clockwise usually positive. So what will be there? W by 2 into L by 2. This L by 2 distance. So W L by 4. Bending moment at C. Listen, see here. This is the point C. So RA. It will rotate like this. What is this rotation? Clockwise. So clockwise from the left side will be positive. Distance, perpendicular distance L by 2. So bending moment will be L by 4. So if we'll draw the point load, shear force diagram will be, I'll write here, shear force diagram will be horizontal line for point load or no load. If UDL will be there, inclined line for UDL. But here in bending moment diagram, if we'll draw the point load or no load, inclined line, UDL parabola. UDL will be the parabola curve line. If UVL will be there, it will be second degree parabola. Once will come, I'll show you. So this now bending moment diagram, inclined line. So bending moment will be maximum at point C. Bending moment diagram will be maximum at point C. So now we'll draw here. So this is the bending moment diagram will be what is? WL by 4. So this is positive bending moment diagram. So this is the theorem. This is the concept for the simply supported beam. Simply supported beam. How we'll take the shear force? Everything is depend upon the sign convention. These sign conventions for shear force diagram. This is sign conventions for bending moment diagram. Line how we'll draw? No load or point load, horizontal line. UDL will be the inclined line. But bending moment, point load or no load, inclined line. If UDL will be the curve line. That only we have to see. So one problems I will take based on this. Then you will understand. So, okay, this is the theorem. If they given point load, not 1, 2, 3, whatever load they will give, we can solve. So this is the theorem. Now we will take one problem and we'll explain this. So I will write one problem here. I will take one problem. What is find the shear force and bending moment diagram for the simply supported beam? What is the question? I will write the different pen. So find shear force, SF na shear force and bending moment diagram for a simply supported beam, for a simply supported beam of length 6 meter. Carries point load 3 kilonewton and 6 kilonewton at a distance of so it's not working, so I will write here at a distance of 2 meter and 4 meter. Distance of 2 meter and 4 meter from left end. So left end, right end, whatever instruction they will give, we have to draw the diagram. So in this like question they will give, diagram they will not give. So they given from left end. So 2 meter and 4 meter both point load will draw. So the given diagrams will be like this. So we'll draw this. Okay. So I will rub it now and we'll solve the questions. Okay. So this is the given diagram. This is point A. So this will be the RA. So from 2 meter, so you take from the 2 meter how much is 3 kilonewton they given, and from the 4 meter 6 kilonewton they given. So okay, so this distance will be 2 meter, then this distance also 2 meter because 4 meter given, and total distance this also 2 meter. This is point B, so this is RB, this also 2 meter. So total distance they given 6 meter. Total distance they given 6 meter. Okay. So how to solve now? See, very simple concept. So we'll see this. First, support reactions we have to calculate. So solution. What is the support reactions? Already you know. Total upward force equal to total downward force. Will take when sigma F B equal to 0 will take. This is the concept. So sometimes now upward force will be positive, downward force will be negative. Finally, what will happen? Total upward force equal to total downward force. So we'll take like this only. So what we can write here? RA plus RB upward force equal to 3 plus 6 equal to 9 kilonewton. Okay. Give equations number 1. Next we'll go. Moment about A will be 0. That means clockwise is equal to anti-clockwise. Total clockwise is equal to total anti-clockwise. So we'll take moment about A. So distance, name you give, this is point C, this is point D. Okay. So we'll take moment about A. This point is fixed. What is the moment? 3 into 2 plus 6 into 4 is equal to RB into 6. This is the moment. So we'll get here RB is equal to, so what we'll get? One steps you write here. 6 plus 24 is equal to RB into 6. That implies RB is equal to 30 by 6. So 5 kilonewton. So what is getting RA and RB? RA. So substitute in equations 1. Substitute RB in equation 1. So what you will get? RA is equal to 9 minus 5 equal to 4 kilonewton. So RA, RB we got the 4 kilonewton and 5 kilonewtons. Correct. So RA will be 4 kilonewton, RB will be 5 kilonewtons. I got it now. Okay. Now we'll find the shear force diagram. First shear force calculations we'll do, then we'll draw the shear force diagram. So before this, what we have to do? We have to do the sign convention. So sign conventions already before also I wrote. What is there? This is section. If right side downward force positive, upward force positive. If we take same section, downward force negative, upward force negative. This is the sign convention. This is a left side. So we are taking from the left side. So shear force diagram calculation. So what we'll see here? So shear force at A, SA. So how many is there here? Upward force going. So upward force left side will be positive. So 4 kilonewton. 4 kilonewton. Then SC. SC means up to A to C, 4. Then now downwards coming. Downward. Left side I am taking downward. What is negative? So minus 3 is equal to 1 kilonewton. Now SD. So 1 kilonewton, then minus 6 kilonewton. Because 6 is downward. Downward is negative. So minus 5 kilonewton. Minus 5 kilonewton SD. Then what will do the SB? SB will be up to this minus 5 kilonewton and upward going how much? Upward going. So upward going, this upward, left side you're taking upward is positive. So 5 plus 5, so 0. So shear force will be. Now we'll draw the shear force diagram. So we'll take this 0 line first. This is called 0 line. In this line shear force will be, shear force will be 0. So okay, so this line you extend. So first what is there? 4 kilonewton. So now you will see here, we will draw the 4 kilonewton at A. Then in this A and C no load. So draw the horizontal line. Then at C, sudden changes will be there. So what is 1 kilonewton is coming. So this point C, this is point A, this also C. Okay. So one here again 1 kilonewton came. Now horizontal line. Here horizontal line. Then SD minus 5. So it will come down negative. Then in this spot no load. So horizontal line. Then shear force at B 0. So you complete this. So this is the 0. So what is the shear force diagram? This positive side, this is the negative side. This is the shear force diagram negative here. Here shear force diagram positive. This is point D, this is point B. A. This is the shear force diagram over. Now we'll extend this line. So we'll draw the bending moment. So first we'll do the calculation, then we'll substitute this value. That will be the bending moment diagram. So for this also we have to sign convention. So sign conventions we will write here. See here, one section is there, right side, left side. Suppose this is clockwise, negative. This is anti-clockwise, negative. If we'll take here from down, this is clockwise, this is ACW, anti-clockwise, no space. So remember, this is section. This is ACW, this is clockwise, will be the positive. This is the sign conventions for this, okay. So sign conventions will follow your bending moment diagram calculation. See here, at point A will be 0 because force is there, no distance. Then bending moment about B, that will be also 0 at point B. So bending moment C and D will come. So bending moment at C, this is the clockwise. Clockwise will be positive. Left side I am taking. So left side clockwise is positive. So what will come here? 4 into distance how much? 2. So 8 kilonewton meter. Now MD we take. So MD na, this 4 into 4 clockwise, 4 into 4 clockwise plus 3. So minus will come because anti-clockwise left side negative. So minus 3 into 2. So 16 minus 6 is equal to 10 kilonewton meter. So and MB will be 0. So we will check here. So this will be the bending moment diagram. Now we'll draw the diagram. So if anything negative, no, so all positive. So draw the 0 bending moment diagram line. This is the 0 line for the bending moment diagram. You write here A, this is B, this is C, this is D. Now all are point load only. So inclined line only will be there. So that I told, no load and point load, horizontal line, inclined line for UDL, inclined line. This is no load line or point load. Here inclined line for point load or no load, and curve will be the UDL. So but here UDL not there na, so inclined line will be there. So up to this how much? MC how much? 8 kilonewton. So will be the 8 kilonewton. Now MD 10. So shear force is 0 at the point D. So maximum So what will be the bending moment will be maximum at point D. How much? 10 kilonewton meter. This is 8 kilonewton meter. This is 0. Now we'll join this. B to A will join this. Here 10 kilonewton meter. Now this will join this line to. So this is the bending moment diagram for point load. So this is very simple. Suppose then point load UDL will be there. That little will be complicated. Positive bending moment diagram. This is shear force diagram negative. So this way we can calculate the shear force and bending moment diagram for the simply supported beam. Okay. Okay, students, watch this video. Theorem and problem both are there in this video. Watch the video beginning to end, you solve, and subscribe the channel, share the video to your friends. Okay. Okay, students, thank you.